Hi, hello everyone. I'm Dr. Chiranjeevi Manike. In previous few videos, I have already explained a few important concepts in high performance computing, that is HPC. In this video, I'm going to explain one very important concept that is related to many other concepts in HPC, that is race condition. And to understand this concept uh, in detail, so I'm going to give a very simple example with simple illustrations and annotations, so that you will understand the what is the race condition, and then we will move on to the coding part. There I'll take a few simple exam and simple sample code to explain what is how the if the race condition is present, and how the output how the result would affected if the race condition is present. So now let us imagine, so you and your friend uh, both try to update the same or want to do the transaction, the two transactions, like one you want to withdraw the money, another is deposit the money at the same time. So what if the system makes a mistake and money is lost or duplicated? So today, now in this video, so we will understand this problem called as a race condition, that is using a simple example here. So let us look at the bank. So here, and this one, that is you are going to withdraw money from the bank same account, and your friend is going to deposit money into that same account. So now let us say, so to understand this, let us say we have a bank account, and bank account has a balance of 1000 rupees. So now the two people, like you and your friend, both want to add, both want to do the two transactions. So you want to withdraw money, that is 100 rupees from their account, and your friend want to deposit 100 rupees into this account. So but if this problem looks very simple, right? But the final value, like how this would impact if the race condition is present. So now let us see one by one. So I just prepared a small simple animation, that is to clearly understand, even the laymen can easily understand what is a race condition here. So now let us see what actually happens inside the system. Like for example, um, like you and you are going to do a transaction, and to do the transaction in a database management systems or database terminology, you are going to read the data item. That is because you want to withdraw the money from this bank account, from a bank account. So that's why he reads a value from he reads a value that is nothing but the bank balance in this account. So that is currently 1000 rupees. And then the second, that is your friend also, because he is also going to deposit money. So for that action or transaction also, he has to read the data item from the bank, that is bank balance. So and both they have read the value, and the same, whatever the balance is same, that is 1000 rupees. Next one is, so that is you are going to withdraw money, that is 100 rupees from the current balance. So then you will withdraw, once you withdraw money, that is 100 rupees from the bank, the bank account, then the balance should be updated to the 900, because 1000 rupees is the previous balance, and once you withdraw 100 rupees, then it will become 900 rupees. And then your friend also read the same account balance, so he want to do this another, that is deposit. So once he deposit, that means he is going to add the money to the account. So then the previous, the balance when he read this data item, so that was 1000. So once he deposit, that is 100 rupees, then it will become 1100 rupees. So 1100, that is like the you updated the bank balance to 900, that is from 1000 to 900, and your friend updated bank balance from 1000 to 1100. So now, and then they have to modify. Once they modify, that means the right operation need to be done to the database in order to update the balance. So let us say, like, first you have updated the bank balance, then as per your withdrawal the bank balance is updated to the 900 rupees. So, and then your friend also updated the bank balance as per this, and now the bank account is 1100. Now if you look at both the values, like, so now let us just understand what just happened now. And this happens because here we expected, because you withdrawn 900 rupees and your friend deposited 100, that is you withdraw 100 rupees and your friend deposited 100 rupees. So that means the account balance after these two transactions, account balance should be same, that is 1000. But here in this case it is showing one account balance like this. After you updated the bank account balance, it's 900, and then it is 1100. So it will show either. So but we expected 1000, but the final value is now here. If suppose let us say you have updated, like your friend updated the bank balance, so recent update, that is a recent update, then it will show the 1100 rupees. So this and suppose if you, and after you have done the update operation, that is a recent operation, then your account, that bank account balance will be 900 rupees. So this happens because both the operations happened simultaneously without a condition coordination. So this problem is called as a race condition. So let us just recall the definition. What is a race condition? A race condition occurs when multiple processes access and modify shared data at the same time, and then that leads to the incorrect results, because like this, and the account balance actual account balance should be 1000 rupees, but instead of that it will show either 900 or 1100. So it is like both like you and your friend were racing to update the value. So how do we fix this problem? How, like suppose this is not a right balance, exact balance. So how we can fix this problem? So we use techniques like previous videos. I've already explained about synchronization constructs like locks, that is also called as a mutex, and the synchronization concept, atomic operations. So these three, like locks, that is, and the synchronization and atomic operations. So these ensure that only the one person update the value at a time. So the correct flow is person A updates. Like for example, here you are the person and you will update and then 900, and then person B reads. So that means, like, if you just go back and like this, and suppose if you want to withdraw 100 rupees from the account balance, and you will read the data item, and you will withdraw the money, and then you will update it. So then after you update, and then we allow your friend to do the transaction. So that means we are not controlling him, but we are not allowing the transaction. So that is a way we can control. So because this ensures only that one person update the value at a time. So that is a correct flow. Either or your friend will be allowed, your friend transaction will be allowed to execute, that means to modify the database, and then and next you will be allowed to modify the database, so that there will be no, so there will be a coordination, and then the final balance will always correct value. So you have to remember, whenever multiple users or processes access the shared data, so we must correctly access, otherwise we get a error like this. So this is called as a race condition. So shared variables are accessible by all the threads. So any modification visible to every thread. So you need to understand this concept. So that is how the race condition is. So now next video I will explain the codes, a very simple C code uh, used in OpenMP, that is to explain how the race condition, if the race condition is present, and how the results would be. Thank you for watching this video. If you like this video, please subscribe, like, and hit the like button and share. Thank you.